The chapter I prepared to show you is about agricultural systems in the 20th and the 21st centuries. Okay, next, please. Okay, next, please. So I prepared these unconventional movements that are not new. So all these movements of non-conventional agriculture started in the let's say in the first quarter of the 20th century, starting with the biodynamic agriculture, as you can see in this organogram. And almost at the same time, we had several other movements like the organic agriculture in the UK and USA. We had this biodynamic agriculture started in Germany and Austria at the same time in 1924, mainly by Rudolf Steiner and then by Mr. Pfeiffer, both people that studied these new ways of making agriculture. In the years 30, we had the organic biological agriculture by Hans Müller, Hans Rusch in Switzerland and Austria. And also the natural agriculture of Mokichi Okada in Japan and Manazobu Fukuoka, which was an expert and agronomist in this area. So we had this spillovers of these movements and the natural evolution that came to the years 70 and 80 with ecological agriculture started by Voigtman in University of Wageningen in the Netherlands, that came directly from the organic agriculture movement of Albert Howard and Rudolf Steiner with the biodynamic agriculture, the regenerative agriculture by Robert Rodale that had started with his father in the 30s and then followed up in the 70s, 80s in the United States. And in the years 70, 80, also the permaculture by Bill Mullinson in Australia, and then the reunion of almost all these trends and movements with the alternative agriculture in 1970, the agroecology of Miguel Altieri from Argentina in the years 80, that was a theoretician that started making modifications in this ways of making unconventional agriculture. And 80-19, we had the sustainable agriculture. So this is just to give you a map of the unconventional movements that are not new. They have started in the first quarter of the 20th century, and they have progressed from then on. Okay, next, please. So we have this virtuous agriculture. The concept is new, in fact. The definition is still to be better delineated because we don't have yet a complete definition of virtuous agriculture. But the concept, which is more important to fix here, is the concept that is linked to these well-defined axes, which call the sustainable use of resources, the balanced use of chemical inputs, the harmonious relations between human beings, soil, and plants. So I think this is the main message of virtuous agriculture that could be linked with the other movements that I have just showed you. So this is an ongoing movement that is been in changes and evolution, and we can go to another step of this kind of agriculture. The next, please. So we have the problem of climate change, and we have the externalities generated by climate change. So in other words, the effects generated by climate change are called externalities, and they reach those who do not participate directly as buyers and sellers. the cost associated with the effect of CO2 emissions is dispersed and falls on the entire society. So those who will increase their margin without adopting the appropriate technology or practices can take advantages of that, of those externalities. And the market also, by the other hand, can reward those who are socially responsible. But this thing doesn't always work. We have this contradiction between conscious consumption with market solutions and non-conscious consumers with market regulation. We have this two trends. So conscious consumers, they see carbon emissions responsible for climate change with emission of GHG, and the market may offer through companies the solutions to reduce carbon emissions that serve their consumers concerned with the effects of global climate change, like seemingly Ili will do. This is a trend that we are seeing. In countries, on the other hand, where producers and consumers are not aware and do not want to internalize the costs of this reduction of carbon emissions, regulatory measures imposed by authorities to curb emissions through command and control mechanisms may take place. But we also know that these mechanisms of command and control are not always efficient. Okay, the next, please. So, in the 20th century, we had the Green Revolution and the challenge of carbon balance. We had incentive solutions, regulatory solutions, and responses from science and technology. And all these items are interlinked, and we will see by the presentations of Mr. Fujihara, Professor Costas, and Professor Chehi. So they will get into more detail into these topics. The next, please. So, just to conclude, there are many trends and movements in the area of healthy agriculture. Let's put it that way. These movements are tending to unite themselves. They're like making a huge front of these movements through the IFOM, which is the International Federation of Organic Agricultural Movements based in UK. We saw the new warning signs in 2020, whether in the political or environmental themes such as global warming, some governments of very important countries taking some actions or not taking any action or getting out of international agreements. We have the global warming that shows signs of being real, independently of the reasons that motivate them. In the agricultural scenario, it's needed urgent measures to be taken. We can make two kinds of mistakes. Moving forward with the adoption of new paradigms and discovering that they would not be necessary. We do not take any measures and discover late that they were necessary. So we must move forward with the spread of virtuous and regenerative agriculture could be a measure of very high benefit to the society as a whole. So, and with that, I would like to finish my presentation here. These are the main topics of the document, and you can go into details reading it and seeing the chapters and the items that we put together. And so that's it. Thank you very much for your attention. Thank you, Chris.
Thank you. Thank you, Sam. Let me just mention a few points before Chris moves on. First, Sam raises very important points, which first, the intentions towards a more balanced farming system is not new. The intentions are present through time, and there are many initiatives worldwide. Sam just mentioned probably the most important, but maybe there are others around the world. Sam also raised 2 points that I think are very important. When you look to the disbalance of carbon in the world that leads to global warming, we're talking about 2 important elements. One, there is a market failure. If you leave the solution to the free market, probably we're not going to have any solution. And then we're gonna go into a very dramatic scenario in the very near future. And then we have the institutional solutions in which you can build better global rules to which the players will adapt in some way. But both the market and the institutions, they will work more or less, provided that the players have the correct incentives to engage in a low carbon and more well-balanced farming system. So this is the point that I would like just to encapsulate the key elements that Sam presented. Thank you very much, Sam. Okay, now we have Marco Fujihara, please.
Okay, thank you very much. The idea of this small presentation is take any ideas about any definitions first about the carbon in the world. Please, Christian, next slide, please. Okay. Some definitions is very important because there are some aspects in terms of definitions, like carbon credit, carbon footprint, carbon negative. There are several definitions about that, but maybe the most important definition is all these definitions is based in Kyoto Protocol the first time, the second time in terms of Paris Agreement. In Kyoto Protocol, there are some countries need carbon reductions, the other countries don't need carbon reductions. In Paris Agreement, all the countries need carbon dioxide reductions. This is a new view, is a new form for understand the scenarios in terms of carbon. But there are 2 things I mentioned in this slide. First of all, internal carbon pricing is a very important concept for, maybe it's a first step if you go to the carbon market or if you go to the metrics in terms of carbon. You need to understand, we need to understand the real internal carbon pricing, how much costs my carbon in my company. This is very easy, but you need some algorithms for that. And because you need marginal cost reductions and opportunity cost the other side. The intersection of this cost is internal carbon price. Several companies in the world will use internal carbon pricing, how is a first step for understand the carbon market. Internal carbon price is very useful for a company, understand investments, understand the marginal costs, something like that. The other thing is very important because there are several kinds of carbon, but gold standard is a carbon offset standard. Offset is everything is offset, but gold standard there are specific offsets in terms of agriculture, in terms of how to use this. It's a voluntary market, it's not a regulatory market, it's only a voluntary specific market. And Verra is, again, is a voluntary carbon market in terms of carbon offset. But for you go to the Verra or for you go to the gold standard, you need to understand the pricing first. Please, next slide, please. Okay, market. There's several markets in the world. The most important market is in this moment is some markets in specific jurisdiction. For example, in California, we have a specific market. It's possible to use agriculture offsets in California market. U.S. markets in Oregon, there are other markets. In several states in U.S., there are specific markets. The global market is how it's possible to use this jurisdictional markets in terms of voluntary standards. Voluntary markets is very important for all the markets. Voluntary markets is very important for the companies. You understand how it's possible transaction these offsets in terms of the real market. There are several types of offsets. In terms of agriculture, there are two most important, VERA and Gold Standard, but the others. And it's very important for understand, okay, voluntary market is a voluntary commitment, not having any commitment for a regulation or something like that. Please, Chris. Okay, but if you go to the voluntary market, you need the project in terms of equality, because there are several mechanisms for how it's possible to determine quality for this project, how it's possible to determine the quality assurance for standards in terms of carbon offsetting. Carbon offsetting needs understanding very quality assurance, because there are several mechanisms and they are very different between one and the other. And maybe if you go to this offsets, you go to the best quality approach, because the market use this best quality. Because if you don't have any commitment for that, it's very important the quality for the offsets in the market. Okay, agriculture have the very good projects in terms of high quality. Here in Brazil, for example, we have several projects in terms of agriculture. There are several very quality approach. Please. Okay, the conclusion. The conclusion is very easy. Brazil is, without doubt, is very important. The big way for carbon market in terms of agriculture and forestry, because first of all, we need all the mechanisms, we need all the ecosystems for that. The question is how you use this kind of ecosystem for introduce the other markets. For example, in Brazil, there are several mechanisms for how it's possible to use these mechanisms in terms of capital markets, because we don't need any regulations for capital market in Brazil, but we need some regulations in terms of agriculture. Brazil have a very, very good expertise in terms of environmental services, not only for carbon and biodiversity and water. In this moment, we conduct the project here in Brazil with World Economic Forum for testing methodology, for testing metrics in terms of biodiversity, carbon, and water. In this case, it's very important to understand that the agricultural markets in Brazil, there are several possibilities in terms of not only for carbon, but carbon and biodiversity and water. Maybe it's a very important thing. And this moment, there are several companies in Brazil use carbon offset for change commodities, for example. In soil, for example, there are some traders use carbon for metrics in terms of carbon, for carbon in the soil, for example. In this moment, there are very important projects here in Brazil, in Bayer, for example, in soybean for carbon in soil. Maybe Eduardo mentioned this in your presentation. Please. Okay, the regulation is very important. The question for regulation in Brazil is not regulations only in Brazil, but the regulations in international market, because you need the regulation for Paris Agreement. Paris Agreement have a lot of doubt about Paris Agreements. Article 6 for Paris Agreement, there are several commitments in this case. But maybe is a very important thing is if you need training before the regulation, maybe it's very important for pay attention in terms of voluntary markets. This is the idea. Before internal carbon pricing, internal carbon pricing, voluntary market, and after that, regulatory market. That's the idea. That's it. Thank you very much, Chris.
Thank you, Marco Fujihara. Thank you very much. Just a few comments like I did before. Marco Fujihara is in his report stressing the possibility of private mechanisms and voluntary solutions. Of course, those are very welcome. If we don't need to touch, if we don't need to care, if things work automatically, then we can have the evolution of a private market for carbon certificates that will offer the incentives that the players need in order to engage in balanced solutions. However, Marco Fujihara, at the beginning of his presentation, he also mentioned that, look, there is this issue of you need to know how to price the carbon. So you have the internal carbon pricing mechanisms, which is not easy. You need some complex mechanisms to measure. So we have a measurement cost. We have some difficulties to move on. Marco also raised an important point that Professor Serri is going to present later on, which has to do with the issue of carbon in the soil, usually neglected in most of the discussions that I have seen so far. So, but this is very important, as Professor Serri is going to show in a few moments. And finally, Marco also stressed one point. Well, regulations are important when markets don't work. And even regulations are difficult to set because you have to have international agreements and you have to have, most of all, international enforcement mechanisms for the different players. This is the big and difficult question that we have ahead. So those points are very important. And thank you very much, Marco Fujihara. Before moving to the next, now, so let me just forward the word to Professor Konstantinos Karantininis.
Thank you very much, Decio. And thank you very much for this opportunity to speak in this audience and do some work for Ili as I'm zipping my coffee, my Ili coffee here. Can you just move to the next slide, past this one? Thank you. Okay. So what I have set to do in this part of the report that I'm responsible of is to look at three different blocks, three different regions, if you want, and how they have reacted and how they are trying to handle this whole thing of the emissions, especially emissions trade and the policies, and also speak a little bit more specifically about agriculture and what is new happening there in terms of the role of agriculture and emissions. So these three blocks are very distinct, and I think I tried to pick up on some characteristics that in my view they are very special and characterize these different blocks. So these are the EU, China, and Africa. The characteristic of EU is what I would, if I would connect to what some of the comments that Decio made earlier about incentives and market failure. I think EU is set out a huge amounts of resources and very aggressive policies to deal with these issues, to give incentives and to try to solve, if you want, mitigate the problems of market failure in emissions. So the EU, in the EU, in terms of emissions, we have three main instruments. The one is the first one is, of course, the ETS, the emissions trading system, which was referred to previously. How countries and factories and industries are trading emissions, and in the EU, this actually refers to, if you want, 11,000 installations, factories, power stations, with main emphasis on power. The second instrument is the effort sharing regulation. So whatever is not covered under ETS, whatever industries are not covered under ETS, the EU member states, they have agreed to reduce greenhouse gas emissions by 2030 and include also sectors that are not under the ETS, such as road transport, buildings, and here is where agriculture belongs in this system. And finally is the LULUCF regulation, which includes land use change, and forestry. And here also the member states ensure that the greenhouse gas emissions from these sectors, converting them into an equivalent of CO2, will be reduced in the period 2021. The EU has set a very ambitious target that by 2050 it will be carbon neutral. And so far, if we trace the success story, if you want, the performance of the EU in terms of reducing carbon emissions, it is on track. But on top of that, EU has taken the opportunity, it has used, if you want, the problem of the climate change as an opportunity, as an instrument of growth. And this is very unique, and as I said, it's very ambitious. So in the beginning of the year, the EU Commission, President of the Commission announced that the Green Deal policy, which basically means that EU is dedicated to 1 trillion euros for the next 30 years until 2050, so this is the new, if you want, the new growth policy of the EU, the new development policy of the EU, which is tied to reducing greenhouse gas emissions and producing sustainably. This is specialized into various packages, various strategies. On top of that is the farm to fork strategy, which refers to producing food sustainably. And this is very much tied to reforming the common agricultural policy. So there is more resources, more funding going into producing food more sustainably in the EU. The other strategy is the biodiversity strategy, to increase biodiversity in the EU. The climate law, which is again, this one is actually more ambitious than all the others because it's already a law, it's already a regulation. So it's an obligation by all member states to follow the climate law. And finally, it's the circular economy strategy. The emissions trading system concerns about 40% of the emissions of the EU in the EU area, and the rest is covered by all the other strategies. As I said, agriculture is under the effort sharing law or effort sharing regulation. So this is the characteristic of EU. If I just close and move to the next one, it is that it has used climate change, the big problem, this challenge, as an opportunity, as a strategy, and to convert Europe, the bloc, into a pioneer into technologies that they will reduce emissions and protect the climate and so on. That's the ambition, and of course this is still under debate. It's still, it has to go through the processes of which are very complex in the European system. Still it hasn't passed all the stages with Parliament, Commission, and Council, and then they have to be ratified by member states and so on. So we will have some years until we see this actually starting to be implemented. If we move to China is a very different beast. It's a very different animal in this one. China is a main polluter, okay, and there has been a lot of pressure to China to reduce this contribution to greenhouse gas emissions and so on. So China has taken this very seriously. In 2018, they made a big political move. They changed the old Ministry of Environmental Protection into a new ministry, the Ministry of Ecology and the Environment, which is, in the Chinese system, that's not very easy to do, and it signals a very serious effort. So far, China is doing some pilot projects, if you want, in different provinces. It's trying different systems. And if we move to the next slide, please, Christiana, sorry. So in the next slide, I basically show some numbers there, a figure with some numbers of these different projects. And I think what is really the characteristic here is that we have different levels of emissions in the different provinces and very different prices. On the right-hand scale axis, you see the prices per ton of CO2 equivalent, and you see the variation there, it's huge. So China is experimenting and has promised that it's going to do this at the national level and will reduce and will become will reduce carbon emissions by 2030 and so on. But I think what is really, there are two things that I want to emphasize here. The first is that a lot of the emissions that are coming out of China are not for Chinese production and consumption, but they're mainly for companies that are, they're multinational companies that are producing in China and exporting all this, all the products. So the emissions, so basically, in a sense, we can say that the rest of the world, especially the developed world, the West, is outsourcing pollution to China. And we have to be honest about that, and we have to face it. For example, a study showed that 75% of all emissions are in the value chain. And in a study that they did in the apparel industry in China, which is polluting a lot, they found that 72% of this production is foreign companies. So they're basically using China as a hub, and they're producing, polluting, and then exporting. So these companies, when they go back home, they're clean because they haven't polluted home. They have polluted through China. So this is something that I think the world has to face. The next slide, please. So the next block I looked is Africa. Africa is again a very different beast. And the characteristic here, if we want to summarize what this is all about Africa, Africa is the smallest polluter, and at the same time, Africa is suffering more than any other continent from climate change. That is what we have to worry about Africa. There is very little going on in terms of trade of emissions. There is only South Africa that is establishing a system of emissions trading, and Senegal, out of all, South Africa is applying a carbon tax, and Senegal also, out of all countries, is trying to has committed that they will apply soon. We don't know when, a carbon tax system, but that's about it. So I think this is the most important thing. And the other thing that we should never forget about Africa is that Africa, most of the emissions in Africa, Africa is a contributor to the LULUS emissions, that is from land use change emissions, because there is conversion of land from wild into agriculture, and there is a lot of emissions there. So Africa is responsible for 20% of the world LULUS emissions, from that type of emissions in the world. And Africa, and again, a lot of these conversions, they're done by Western multinational companies. They're not African companies that are doing that. So that is also something that we should note. Finally, I will close with a little bit of discussion about agriculture. What we have to, the main characteristic here with agriculture is that agriculture in the last 12,000 years, which we know that we have agriculture, has taxed the topsoil, the top 1 meter of soil, by about 133 billion tons of carbon. And we still do not know where this carbon went, if it went to the atmosphere or if it was just a runoff into water. But what is becoming interesting, and it is coming very much into discussions, especially if one follows what's happening in Europe, this is really a hot topic. It is every day there is some news on this, is how we can use agriculture as a carbon sink. Okay, because agriculture has the capacity to remove carbon from the atmosphere. Every year, 30% of the CO2 of the atmosphere is absorbed by plants in the world, all over the world. And a lot of this carbon that is absorbed through CO2 is going down into the soil, and it's converted by bacteria and other organisms into organic matter. So agriculture has a tremendous potential. And now it is again going back to the past, that this comment that Decio made earlier about incentives. So now it is a problem of finding the right incentives to make agriculture to be a carbon sink, to be a contributor to the reduction of carbon, instead of being a producer of carbon. And of course, we should never forget that this is a problem that cannot be solved by markets. Decio mentioned market failure here. So this has to be done by policies, by instruments, by policymakers, because the markets still are not in a position to solve this problem. And I think now the discussion, especially in the EU, is number one, whether agriculture will be part of the ETS to trade. And also in my report, I have highlighted a few private initiatives worldwide which are trying to, through collaborations between public and private entities and farmers, to incentivize farmers to reduce, to sink carbon and be paid for it, and produce certificates that can be traded, hopefully, in the market in the near future, or could be used and bought in a private manner by companies as a carbon credit. So these are my contributions. I hope I didn't overrun my time. Thank you very much.
Thank you, Kostas. Thank you very much. You always bring some shaking ideas that keep us to think in depth, and you show how complex the questions are. If I can encapsulate some points from your presentation before moving on, you brought first the big challenges of your European community to look to 2050 to be carbon neutral, which is not an easy task. You also brought the point that the legislation and the incentives connected to the from farm to fork approach, which is very interesting, and bring some other issues into the game, which some of the products that goes to the fork in Europe comes from a farm from elsewhere. So this complexity of farming systems and agribusiness systems in general, in which you have some activities being conducted in one country, in one continent, but the consumption elsewhere, brings some important elements, as you brought, particularly with regard to China. And then when you look to China, you brought a very, I think you touched a very important point, where in some way the world is taking that kind of NIMBY approach, not in my backyard. We are exporting pollution to China in some way. But this is undercover. It's not easy to see, and you brought this point very, very important. And then you brought the African issue, the issue of being a continent which so far is a low pollutant, but also shows some big impacts in terms of transforming non-farming into farming areas. And this is the same that happens in Brazil, and the big discussion that we have right now with the incorporation of into farming of so far untouched systems and biosystems. And I'm not talking only about Amazon, but also about the Cerrado areas, which are also very relevant. And finally, you brought one point that I like very much, because this almost in some way just connect to the next presentation. You look into the issue of carbon in the soil and agriculture as an activity that humankind learn how to explore in some way is a high impact. If we add the impacts through time, it's a very big impact in terms of carbon. And then you raise the question that maybe Sari can help us to discuss and to understand to where this carbon goes. So, which is a very important issue and a very important applied issue. So, Kostas, thank you very much. I think you brought a very big contribution to our effort. And now I'd like to move to Carlos Cherry. Please, Carlos.
Thank you, Professor Décio. First of all, I would like to thank the opportunity to talk to you today and discuss a little bit about methods of measuring soil carbon stocks. It's a general view for agriculture, but also in the document, as you may have the opportunity to see, we have a section also dedicated on coffee production. So here, in the short time I have, I'd like to, as an initial consideration, you all know about this, but to show you that soil carbon is very important and relevant for the global carbon pool. So the figures I will show you here is in this unit of petagrams of carbon. Peta means gigatons or billion tons of carbon. So as you know, in the atmosphere, we have about 750, 760 petagrams of carbon. The vegetation, globally speaking, we have about 500, 550 as a medium, as an average value for as carbon in the vegetation, globally speaking. And in the soil, if we take the first meter, soil layer, we have 3 times the amount of carbon we find in the vegetation and 2 times at least the amount we find in the atmosphere. So this is an important pool of carbon, and the changes in this pool may modify the global carbon cycle. Some people say, yeah, but 1 meter is a lot. So let's say that in the first 30 centimeters, the arable land, arable layer, we have about 800 billion tons of carbon. So this amount, just for you to have an idea, is equivalent to the amount of carbon that terrestrial ecosystem may uptake every year. So it's very important. So if we do not pay attention on this layer, what is going to happen, as you know, is carbon from the soil as organic matter will be emitted to the atmosphere. And as a consequence, we are going to increase the concentration of carbon in the atmosphere, which we do not like to do this. We want to do, ideally, the opposite, which is remove carbon, remove CO2 from the atmosphere by photosynthesis, and part of this carbon in the vegetation will be transformed to carbon into the soil. as I said before, soil organic matter components or fractions. And as you all know, soil organic matter is very important because it interacts with soil chemistry, soil physical attributes, soil biological attributes. So, and in general, soil organic matter helps to improve soils for plant development. So what we want to do is to sequester carbon through vegetation and soil, and of course, reduce the carbon concentration in the atmosphere. So soil carbon, it's an important pool, but the hard part is to measure it. So first, we need to understand the dynamics of soil carbon. So if you have a vegetation, a native vegetation, we usually say that soil carbon in this condition is in equilibrium, in a steady state. So you have gains and losses of carbon, but they are equivalent. So carbon stocks are somehow in equilibrium. What happens if you you cut and slash and burn this vegetation through deforestation, for example, as Professor Décio just said, could be the Amazon, could be Cerrado, could be any type of native vegetation. You have the burning process, you transfer carbon from the plant to the atmosphere as greenhouse gases. I put here 3 of them, the most important gases for the agricultural sector, CO2, N2O, and CH4. But you have an additional problem here. Because of deforestation, you stop carbon additions. So the organisms in the soil, microorganisms, they like to keep their activities, their metabolics, so they will consume, they will use soil organic matter. So through time, there is a potential reduction, and this carbon into the soil, that was in the soil, is again emitted to the atmosphere. So we have 2 problems. We have the transformation of vegetation and also the soil to greenhouse gases. But we can have another land use. As Professor Konstantino mentioned, there is this land use change. And this new crop can add carbon to the soil. But the problem is, imagine if we have a degraded pasture. Usually the amount of carbon added to the system is low. So the levels of carbon stock now may reach a new equilibrium. But this new equilibrium, as you can see here, is far below the initial condition. But it could be not degraded pasture. It could be well-managed pasture or coffee plantation or integration of livestock agriculture or agro-silvopastoral system. So integrated system that cover the soil, that adds as material input carbon very frequently and ideally with different conditions and types, they can improve soil carbon. And it's not unusual to find situations where the amount of carbon after land use change is similar to the previous condition. I'm not saying that the quality of this soil carbon is the same, but the amount may be the same. And in some cases, for the 30 centimeters, may be even higher the previous land use, the native vegetation. This is common to be seen in the literature. But so we have a dynamic here. You have the native condition and then land use change and a new crop. And depending on the management practice of this new crop, you can have carbon sequestration in different levels, in different amounts. And this is discussed in the document, but I do not have time to go deeper here. So we have, considering this context, we have few approach to estimate soil carbon stocks, the amount of carbon in a certain layer. One group of approaches, they are based on tools, on mathematical tools. And here I can include simulation models. You may have heard about carbon simulation models like Rothamsted carbon model, the MDC model, Century ecosystem model, Descent, terrestrial ecosystem model. Many of these models are available to estimate based on equations, on routines, mathematical routines. You have another option here, which is Exact, which is a tool, spreadsheet produced by FAO, and which helps us to predict the amount of carbon. Similarly to this carbon benefit project that has 3 tiers of calculations. I will not give you too much details, but I will be happy to answer any questions you may have about that. But what I wanted to emphasize here, this type of approach using mathematical tools, they are very nice, but they need to be calibrated, parameterized, and validated. And sometimes we do not have measure data to do that. So the scenarios must be validated previously so we need to be sure that those models are working well before doing some scenarios. So this is one difficulty. Another approach would be using frameworks. For example, calculation methods. And as an example here, I brought for you the IPCC, the Intergovernmental Panel on Climate Change approach. They have tier 1, tier 2, and tier 3, so levels of complexities. And basically tier 1 and tier 2 that are the most used in the national inventories worldwide. So tier 1, basically you multiply the emission factor by activity data. Tier 2 is the same, but you use more specific data to be multiplied. And tier 3 uses some of these mathematical tools. And finally here, I put this as last option here, but this one I wanted to emphasize is related to direct measurement. So the idea is to go to the field, to get samples and to analyze carbon to give a more reliable results on approaches for estimating soil carbon stock. So I will give a little bit of more details about this last item here. So the idea, my friends, is to find a place where you want to access soil carbon stocks. To go to the field, you have to identify, this case here, we have 3 land uses, native vegetation here, in the middle we have sugarcane and pasture. So we have to open soil pits there, we have to take samples from those areas, and take these samples, have to prepare at the lab and analyze them. And there are few methods to analyze soil carbon content. And this one I am showing here is one of the methods called dry combustion, which is the best method we have today as a standard method for calculating or for determining soil carbon content. So basically the idea is to go to the field, take samples in different layers, usually every 10 centimeters to 1 meter, and then we take these samples not only for carbon but also for bulk density, because as you may know, in this simple equation about soil carbon stocks, you have to multiply the carbon content of that sample, the bulk density of the soil for the same layer, and the thickness of this layer. If it's 10 centimeters, 5, 15. So it is a simple equation here, but it's not that simple to do it in the field. It's not easy to get bulk density. It's not easy to take samples in the field in different conditions, in different layers. So, but anyway, this is the direct measurement type of approach. And usually in those IPCC or other frameworks and national inventories, they express carbon stocks in kilograms of carbon per hectare or per square meter, or megagrams or tons of carbon per hectare. So those are the main units that we find. So I try to put in the text in the document. I had the opportunity to describe each method. Here I will try to summarize in a single figure. So we have assessment levels of soil carbon stocks. And the level 1, I called level 1, determination of carbon content using a wet oxidation method at the lab. The problem is that this method usually underestimate soil carbon content and is not very precise, not very reliable. It's possible to be done, but there are some tricky parts on that. And also in this level 1, you can estimate bulk density, for example, using pedo transfer equations. So basically use other soil attributes to estimate bulk density. This is the level 1. Level 2, it's a little bit improved. You will still have wet oxidation. Why? Because it's cheap to be done. Almost any lab can do this because there is no need of a specific equipment or very fancy and expensive equipment. So the level 2, you improve a little bit by measuring bulk density, because as you remember in the previous equation, you multiply and there is no weight. So there is no sense to go very deep on one member of that equation and forget about the others. So this is a level 3 intermediate. And level 3, which I believe, and all these documents believe it's best way to direct measure soil carbon, is not only measuring carbon content at the lab, but using dry combustion, because in this method, you take a sample and there is an oven in this equipment at 1,500 Celsius degrees, so very high temperature. All carbon in that sample will be transformed, released as CO2, and there is an infrared detector that measures the CO2. So it's very reliable. It's a very, I would say, very precise way of measuring soil carbon, and also measuring here bulk density. So in this sense, we have, going to level 1 to level 3, a more complex way of sampling and at the lab. But on the other hand, to reduce the uncertainty associated to that result. So level 3 is, you have a lower uncertainty compared to level 1, all of them as direct measurements. So to finish that, it's not easy because it's ideally level 3 should be done, but you need a specific equipment. All the chemicals, the consumables are expensive. So, and you need to take your samples from the field, which is also not easy. But in my opinion, this is the right way, and this is being required. For example, if people like to give a broader view about any product, for example, in this case, coffee. So what's the carbon balance for a coffee production? What's the carbon footprint associated to that? Not only the emissions associated in the carbon footprint, as Professor Fujihara already explained, but also in the near future, and for some commodities, we already do that, is not only taking into account the emissions associated, but also the sequestration, the fixations, the offsets associated to that. From the planting to the harvest, all the sectors here, the industrial phase, the transportation. So for a fair carbon balance, we should take into account not only the emissions, but also in the agricultural sector, it's possible to sequester, and the balance would be the difference about this. So this is what I planned to show here in the limited time. Thank you very much for the opportunity.